In this lecture, I'm going to take everything which we have learned so far and put it into creating a real-world simulation application. I will use the same concepts for inventory which we have seen so far, like safety stock, reorder point, reorder quantity, and so on, but applied in a more class-based Python approach. So what will this app simulate basically? So based on the base parameters of your inventory, of your item basically, it will give me a series of visualizations for the full year, and I would be able to visualize the different aspects of inventory, such as inventory level over time, the order pattern, the costs over time, breakdown of the cost, etc. So let's see how the app actually works. So if I go and check, all of the magic happens basically in this deterministic inventory class. And the most simplest way of explaining what a class is, generally speaking, in programming languages, is that it's a place where you can store your functions, the state of your variables, encapsulate your method in one place. Obviously, there are so many other things about it, but this is what we want to know for the purposes of this particular lecture. So to explain the structure of this program, I will draw the skeleton of this particular. So for this app, think of it as a canvas on which you can put your methods, variables, states, etc. So let's say this is my class, and I'm going to have my base parameters here. So this will be my one block. My second block will be my key functions which take the flow of the program forward. For example, demand generation, ordering of items, etc. Then there will be variables which keep track of the program itself, of the different states of different variables. So this will be like tracking. And there will be functions which basically plot the output which we have seen. And we'll simulate this program for a period of 1 year, and we will start with an inventory level of 0. So let's look at the code more concretely. So to start off, I will create something called as Python data class, and this is basically a special kind of Python class where you can actually put all of your variables in one place, as well as your functions, and define the types of your variables. So in this case, we have a inventory parameters data class, which basically contains our key state variables which we want to keep track of. So for example, annual demand, ordering cost, holding cost, lead time days, and so on. Then we'll start off with our main class. And whenever you initialize a Python class, you always use a certain set of magic methods. So for example, we have the initiation function defined by the init keyword, and this always takes the self parameter as well as the other parameters, which basically comes from this particular data class. For EOQ, we will use something called as encapsulation. Encapsulation method means that basically instead of defining it directly, we use something called as a class method or a private method, so that we don't allow the variable to be changed directly from outside. And this is another one of computer science concepts. Then we have the daily demand, which we have seen earlier. We have the reorder point. We create the variable current inventory to keep track of our current inventory. And the pending orders will be just an array list which will keep track of our orders in transit. And we can also have a history variable which will keep daily track of the metrics for analysis. We can use it to create charts later on. So then basically we start with our main methods. So we start with calculate EOQ or reorder quantity, and a dash at the start of a Python function generally means it's a private method. Since Python, unlike Java, doesn't have the keyword for private, public, and this basically is the same formula which we have seen earlier for EOQ. And then we define our daily costs. So these are basically the cost we incur from daily ordering as well as storing our items. Then we come to the main function, which basically simulates the flow of the program. So the key activities which it will simulate will be basically the processing of arriving orders, the processing of daily demand, the processing if we need to trigger a new order based on our current balance and reorder point, as well as the process of calculating the cost for each day. And basically it's the same approach which we have seen earlier in the previous lectures. So for example, we'll do a basic iteration over the number of days, and then there will be subsections of code which basically simulate the different sections of simulation. So for example, this processes in the new order. This will add the new orders to the current inventory. This will check if you want to trigger a new order, and so on. And essentially it's just simulating the same process of the inventory, where we have a certain item with a certain level, and it's decrementing every day based on the demand until the time it hits the reorder point, where it generates an order, and then the order is then processed based on the lead time and then added to the current level of inventory. And the process goes on and on. And once you have done that, the next part is just calculating the service level, the fill rate, as well as performing the visualizations as done basically in these functions. So we'll plot the results here. We'll plot the inventory level, order pattern, cost breakdowns, etc. So here we sort of plot the main figure, which contains our subplots using the matplotlib library, and this is just a data frame which is holding the history, which is basically the variable which we created at the start. And data frame, as you know, is a pandas object used widely in different Python packages. And then we successively plot different plots. For example, this is plot inventory level over time. Again, we are using the same concepts of matplotlib library and the same API functions. So for example, plot, horizontal line, set title, X label, Y label, and so on. And basically you can use this piece of code or the app and try on a single item. Let's say we have a single item with 10,000 units of annual demand per year, $100 per ordering cost, holding cost of 20 per unit per year, and 5 days lead time, and starting with 500 units. And you will end up with these visualizations. And then you can use these basically with your business to basically analyze effectiveness of your inventory methods in terms of costs as related to your overall business expenses. So for example, we have the cumulative cost over the period of time, as well as check other things. For example, your operational aspect of procurement. So you can check when the order pattern shows the orders are generated over the period of 1 year. So for example, do I need to hire more staff, more buyers, etc. To summarize then, we have looked in this lecture a comprehensive inventory simulation system which have all the basic aspects of a world-class system, starting from setting our parameters for the particular item, and this can be extended to even your full inventory using very minor modifications. And as a matter of fact, this can also be linked to your inventory management systems using a simple API. And in the next series of lectures, we will see how to take this further and apply something called as discrete event simulation methods to make our inventory more robust and more real world like, similar to our real world challenges in terms of adding more variation for the key parameters of demand and lead time, etc., as well as finding the optimal parameters for our inventory without using complex mathematics.